Good morning. So today I'm doing grade 10. You remember yesterday I did the atmosphere. This is our paper 1. I did the atmosphere yesterday. So today I'm moving on to geomorphology grade 10. I'm moving on to geomorphology grade 10 now. Guys, remember I'm operating from the assumption that your teacher have explained everything in detail and you have an idea. I'm not operating with someone who is blank, who does not even know anything. At least you have got an idea. You can now connect what you have learned with the information that I'm providing. But I'll try by all means to provide as much information as possible to make things easier for you. That's the ideology behind my page, my TikTok page, is to simplify geography. That's why it's written FET, Simplified Geography, to make it simple, to helping you to be passionate about the subject. That's why I'm here. Let's go through it, but it does not mean that I'm the messiah of the subject. I might have some of the things that I might have missed out, 1 or 2 things. We are here to complement each other. Whatever you know, whatever you feel that I did not do right, please, you are free to comment, then we can correct it. It might be a slip of a tongue, something that I've missed, something that I did not explain in a way that you expected. You are free to comment and contribute as well. Remember, we are not competing. We are here to help each other. The way you understand, the way your educators explain to you, then we can come up with something that will simplify the subject, something that will help us to have a better comprehension of the subject. So let's do it. Geomorphology. Remember, I've covered the atmosphere already, so we are going through geomorphology now. So various options are provided as possible answers to the following questions. Choose the correct answer and write only the letter A to D next to the question numbers. So this is what we have, guys. These are the questions that we have, geomorphology for grade 10. Remember what we look at. Of course, I'm not going to be specific on the topics, but I'll explain as we go. So the first question now is it's just something to do with the intrusions. Okay, so when it comes to igneous rocks, we have got what we call the intrusive igneous rocks, then we have got the extrusive. So when you talk about the intrusive, I just want to explain a bit. We have got this that explained within the crust. Remember, the structure of our earth is made up of the inner core, the mantle, then we have got what we call the crust. So what happens is, in the mantle, the rock is in molten stage, which means it's more like in liquid state. So if anything happens in terms of volcanicity, in terms of maybe the earthquakes, which means they create the line of weakness where the molten material that is within the mantle can now go out. But however, when it's slightly below the crust, what happens is it starts to solidify because there are changes in temperatures. The temperatures that we have within the mantle, they are very high. That's why it's in liquid state. So this is when we started to have what we call the intrusive igneous rocks, okay, the intrusive volcanism, okay. That's where we've got the batholith, we've got the laccolith, we've got the the different intrusive. So if it's extrusive, it means on the earth's surface. Intrusive, it means slightly below the crust. That's basically what we're talking about. We're talking about your batholith, laccolith, your loccolith, your seal, your dike. I just wanted you to have an idea. That's why I had to come with this. Let's go through it now. So is the largest of igneous intrusions. So your answer there is your batholith. Is your batholith. Okay, your batholith. You remember, of course, you are going to do more of this in grade 10 when you also look at some of them landforms that actually develop from the batholith, from the laccolith. Okay, let's just be simple. Let me not confuse you. So that's the largest intrusions, okay, which means it's formed slightly below the earth crust. That's why we call it intrusive. It's still within the crust. If it's on the earth's surface, that's extrusive. That we're talking about what we call the extrusive. It's an extrusive now because it's on the earth's surface. If it's still within, that's an intrusion. Okay, batholith. Then the outer layer of the earth that consists of solid rocks are called. This is the outer layer of the earth that consists, of course, that can be your crust. The outer layer. You remember, we have got the inner core, we have got the outer core, we have got the mantle, then we have got the crust. So that is your crust. The single landmass that existed over years ago, that is your Pangea. That is your Pangea, which is B. That is your Pangea. Okay, then the theory that continents were once a landmass that drifted apart from each other. We are now talking about what we call what we call this. That is your continental drift. Okay, the theory that continents were once one forms that drifted out from, that is your continental drift. Okay, but also known as the plate tectonics. Okay, the study of the Earth's physical features and process that form them is called, that is your geomorphology. Geomorphology. Okay, then a mushroom-shaped structure that forms when magma forces way upwards is, okay, mushroom shape 2.1.6, 2.1.6, that is your D, which is your laccolith, we are talking about this. This is a mushroom shape. We are talking about this. This is a mushroom shaped. Okay, that is your laccolith, like an arc. Lapo is saucer based. This is lopolith, is saucer based. This is mushroom shaped laccolith. Okay, then which of the following are landforms associated with extrusive? Okay, remember I was talking about intrusive, extrusive, igneous rock, which means this one you find them on the surface above the crust. So here you've got your mesa, your butte, and your conical here. This is intrusive, this is intrusive, extrusive, this is intrusive, extrusive. So the correct one here is D. Okay, let's move on to the next question. That is 2.1. Okay, 2.8, sorry. The cycle of rock formation, I think this one is straight to, that's a rock cycle. Okay, it's already there. I mean, it's nothing to do with metamorphic cycle or whatever. That is a rock cycle. Okay, which is the stages in the formation of rocks. Okay, that's basically what we're talking about. Refer to the Fig 2.2, which shows the structure of the Earth. Remember the structure of the Earth, guys. We've talked about the structure of the Earth, showing the inner core, the mantle, showing the crust. But this one, it has something to do with the earthquake now. To be specific, there's something to do with earthquake and how it actually takes place. So you need to be in a position to know, when it comes to the earthquake, where are you likely to have your focus, where the earthquake originates, the epicenter, where the first impacts are felt, the seismic waves, okay, the fault line, all those things. You need to be aware in terms of labeling. So I'll just label a few. Okay, so your A here, obviously this is where the earthquake originates, that is your focus. Then your B, obviously we are talking about the epicenter, where the first effects are felt. Okay, epicenter. Then you see these are seismic waves. Okay, we're talking about your seismic waves now. Then your D, obviously that becomes a fault line. That becomes your what? Your fault line. That becomes your fault line. So once you have a general idea in as far as the structure of the earthquake is concerned, then you are better off. You're not going to struggle with anything. So you should be aware when you look at the diagram, the structure of the earthquake, where do you find your focus? Where are you likely to find your epicenter? Where are you likely to find your seismic waves? Where are you likely to find your epicenter? So this makes your life easier. You should be able to know this diagram and also how to label it. There's no way you're going to be asked to draw it, but you can only label. So you need to know that, okay, where it originates, that is the focus. Where the first impacts are felt, of course, you are talking about your epicenter. The movement, of course, in terms of shock, okay, that is your seismic waves, okay, and so on and so on. What instrument is used, the Richter scale, and so on and so on. So let's go now. Vibration of the Earth's surface is called, that is your earthquake. It's even here, guys. This is what we're talking about, okay? Then label the igneous intrusions indicated by letters A, B, C, and D as the focus. Guys, you are even given epicenter, seismic waves, and the fault line. So you need to know now. You are even given, you just have to label. You have to be able to identify them. So this is the same thing that I'm doing now, yeah? You are supposed to be able to identify them, of which that's what I've done. I've been able to identify them. So these are the different, okay? The focus, the epicenters, the seismic waves, and the fault line, okay? Then what else? Let's move on to the next one. An earthquake, so I've labeled the focus, epicenter, seismic wave, and the fault line. That's what we have done, which means we are done with that one. We have got our 4 marks. An earthquake of over 8.0 magnitude on a Richter scale indicates, of course, a Richter scale, that's what we use to measure how destructive the earthquake is. That's a Richter scale. You have to know about it. You can come across it under multiple choice. So it's more destructive. That's what it means here. It's more destructive. It's 8.0. Then is an instrument that measures the magnitudes of the seismic waves. Of course, that is a small seismography, not barometer. Seismography. That is your answer there. Let's move on to the seismography. So which means we are done with the first part, that is 2.1 and 2.2. So boys and girls, we are done with the part that is 2.1 and 2.2. The first question was out of 8, the second one is out of 7 marks. So thank you. Please don't forget to reshare, don't forget to repost, share, like, and also subscribe. Thank you so much.